Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge IGCSE Add Maths paper 2, which is the one which you can use calculator, specimen paper B for exams from 2025. You can give non-exact answers to 3 significant figures or 1 decimal place in angles, unless of course something else is given in the question. And for pi you can use calculator value of 3.142, and I'm going to be using the calculator value. Let's start. Question 1. Just note that you cannot just draw this information which is here, and even if you do try that, you won't be given any marks for this question. So you have to do the question in the way using coordinate geometry. A circle has center 3,2 and radius 17. A different circle has center 15, minus 4 and radius 29. A. Show that the circles have 2 points of intersection. Well, to show that the circles have 2 points of intersection, let's just visualize it by a rough drawing of 2 circles which have 2 points of intersection. These are the centers. So this is one radius and this is the second radius. And the distance between the centers is this much. And since the circles overlap, as we can see like this, the circles overlap over here, this region, like a Venn diagram, and this radius plus this length is the distance, and this length is evidently less than the radius of this circle. So the sum of the two radius over here, this one and this one, is greater than the distance between the centers. So we can find the sum of the radius. That's 29 plus 17, which is equal to 46. Now let's find the distance between the centers. So doing this is x2 minus x1 the whole squared plus y2 minus y1 the whole squared, and we take a square root of the whole thing. This makes, let's take this as x2 comma y2, x1 comma y1 there. So we get 15 minus 3 the whole squared plus minus 4 minus 2 the whole squared, and of course we square root this, which is equal to the square root of 180. And this is of course the distance between the centers. And obviously this square root of 180, you can use a calculator as well and find it out. Taking this 13.4, which is clearly less than 46, and therefore the circles have 2 points of intersection. And well, that is our answer. Let's go to part B. The points of intersection are minus 5, 17 and minus 13.8, minus 0.6. Using this information or otherwise, find the equation of the common chord. Well, if we imagine two circles which intersect at 2 points, the common chord is simply the line joining these 2 points. And of course, this diagram which I draw is not to scale, but this line here is the common chord. And how do you find the equation of a line joining 2 points? We know the 2 points, so we can find the gradient and y-intercept like you do for a normal line. And the gradient here, that's just m, and we use the typical gradient formula, which gives 17.6 by 8.8, which is 2. And by the way, for this formula, I've taken this as x2 comma y2 and this part as x1 comma y1 because it gives positive values. But if you take it the other way around, the answer is still going to be 2. And now how do we find c? Let's take this point here, and we have the equation y equals mx plus c, and c is the y-intercept. Now we have x comma y here, and we have m over here. So we can substitute these in. 17 is equal to 2 times minus 5 plus c, and c is simply 27. So the common chord equation is just y is equal to 2x plus 27. And that'll be our answer. Let's go to question 2. For variables x and y, plotting log y against x to the power 4 gives a straight line which passes through the points 2, 5 and 6, 7. A. Find the value of log y when x to the power of 4 is equal to 0. Well, let's just assume that log y is capital Y and x to the power 4 is capital X. This is basically converting these non-linear values into linear form. by making it as capital Y and capital X. And because this straight line using capital X and capital Y pass through 2 points, we can find the equation of the straight line. So we can use the gradient formula, which we used in the last part as well. So let's take this as x2 comma y2. This is x1 comma y1. And when you do that, we get half as our gradient. And now we can substitute this into y equals mx plus c, but in this case I've written capital Y and capital X because this is what forms a straight line. Only when we plot capital Y, which is log y, against capital X, which is x to the power 4, it gives a straight line. If you plot these as small x and small y, of course these are not going to give a straight line. It's a log function and it's a 4th degree function. So of course we just substitute over here. Oh yes, sorry, these are capital x2 comma y2. Same for this one here. I'm just writing like this so it doesn't confuse you, and you can see that these are only for capital letters x and y. And now the line equation. We have, let's take this point here, 2 comma 5, and we have m already, which is half. So half times 2 is equal to 5 plus c, and c is equal to 4 because of that. And of course we could just write down the line equation from what we calculated here, the gradient y-intercept, but we can see the question asks when x to the power 4 is equal to 0. This basically means capital X is equal to 0, and that is the y-intercept. And we already found the y-intercept. So this value c equals 4 is the y-intercept. So the value of log y at x to the power 4 is equal to 0 is just 4. So this will be our answer. Let's go to part B. Given that y can be written in the form ab to the power of cx to the power of 4, where a, b, c are constants, find these 3 values. Well, we found the line equation for y equals mx plus c. We can just substitute the values. Y is equal to half times capital X plus 4. Now we can actually substitute these log y and x to the power 4 back. So log y is equal to half x to the power 4 plus 4. And y is simply going to be equal to 10 to the power of this over here. And this can be written as, we can split this into 2 separate terms. So 10 to the power of 4 times 10 to the power of half x to the power of 4. And this is just 10,000 times 10 to the power of half x to the power of 4. And this is in the form of a b to the power of c x to the power of 4. So this x to the power of 4 is here. A is simply the one without the exponent, which is 10,000. B is the base of the exponential part, which is 10. And c is the coefficient of the x to the power of 4 here. So a is equal to 10,000, b is equal to 10, and c is equal to half. And that's our answer. Question 3. In the expression 12x cubed plus ax squared minus 12x plus b, a and b are integers. The expression has these 2 things: a factor of x minus 2 and a remainder of negative 15 when divided by x plus 1. Find the other linear factors of this expression. And by other, because we already have one factor, so we just need to find the other 2. Remember that factor basically means the remainder equals 0. And we can use the factor theorem and the remainder theorem to find our answers. So if the factor of x minus 2 causes the remainder to be 0, that basically means that, let's call this p of x. That means p of 2 is equal to 0. Why 2? Because we have x minus n. And if this x minus n is a factor of a polynomial p of x, that means p of n is equal to 0. So here x minus n is x minus 2. So n is equal to 2, and that's why you put 2 over here. And over here, using remainder theorem, it's a very similar thing. It's just that over here we have x minus n, which is x plus 1. So n will be equal to minus 1. P of minus 1 in this case is not going to be equal to 0, because in this case, it does not give a remainder of 0. It gives a negative 15 remainder. And therefore, P of negative 1 is minus 15. The one I described here is the factor theorem. The one I described below is the remainder theorem. And using both of these, we can find two different equations for A and B. So let's see that in action. P of 2 is just 12 times 2 cubed plus A times 2 squared minus 12 times 2 plus B. That's equal to 0. And now when we do this, 4A plus B plus 72 is equal to 0. And we can write 4A plus B is equal to minus 72. And this is our first equation we found. Now what about the second one? We have P of minus 1 is negative 15. So we just substitute minus 1 into the equation. And over here, we write is equal to negative 15. So this minus 1 squared is just 1. So A plus B will be here. And what is the constant? This is equal to minus 12. This is equal to positive 12. And they cancel out. And this negative 15 remains here. So A plus B is equal to negative 15. This is the second equation. Now we can solve these like normal simultaneous equation. We have the B term in both equations which have the same coefficient, which is 1. So we can eliminate the B term. We can do 1 minus 2. And that will be 4A plus B equals minus 72. And we subtract the whole equation off. So this will become minus A minus B is equal to 15. And we add these two. So the B's will cancel out. These will cancel out. And 4A minus A is 3A. Negative 72 minus negative 15. That's minus 72 plus 15, which is minus 57. So A is equal to minus 19. We have our A value. Now what about B? We know that A plus B is equal to minus 15. So we just substitute this here. B is equal to 4. Well, this is not the end of the question. They've asked us to find the other linear factors of this expression. So finding A and B is not enough. Well, we know P of x now. So 12x cubed minus 19x squared minus 12x plus 4. But we need to find the other factors as well. So first thing we can do is we know one factor here. And we can just divide this whole expression by the factor. And we can use a simple long division method, but in this case for a polynomial. Let's just move this over here. And I'll do some long division. We have the equation here, the expression for P of x. And we divide this by the factor which we know x minus 2. So let's take this term first, 12x cubed. How do we make x into 12x cubed? Of course, we have to multiply by 12x squared. So 12x squared comes in our quotient. And now we multiply the whole thing in the factor by 12x squared. And this becomes 12x cubed minus 24x squared. And now we can subtract it off from the dividend over here. And this becomes 5x squared minus 12x. Using the same thing, we get plus 5x here. 5x squared minus 10x. And when we subtract it off, minus 2x and plus 4. And we get minus 2. So when we subtract it off, it becomes 0. And therefore, we know that P of x can be written as this factor x minus 2 times the factor we just found, 12x squared plus 5x minus 2. But let's carry this over to next page. Of course, probably if you're writing an exam, then you'll have to finish it in the required space, but in that case you could just write it smaller in order to finish it in one page. Well, here I have the luxury to use more, so I'll just use it. And let's just copy the P of x expression and write it in the new page. So here we are. This is the new P of x. And now we have to find the other linear factors of the expression according to the question. So we can't leave it like this. We have to find this in terms of two linear factors. This is a quadratic, and therefore, if we can find the factors of this, it would be great. That would be our answers. And of course, we can find the factors. So 12x squared plus 5x minus 2. How do we find the factors? We take the a value and c value. ax squared plus bx plus c. We have a is equal to 12, b is equal to 5, c is equal to minus 2. Now let's multiply a and c. We get negative 24. So let's just imagine that this expression was x squared plus 5x minus 24. How do you factorize this? This is much simpler since the x squared term has coefficient of positive 1. So it's much easier, and with a bit of trial and error or splitting the middle term, you can find this to be x plus 8 times x minus 3. Well, now this is for this expression, but what about one with 12x squared at the beginning? But we know that 12 is equal to 2 times 2 times 3. So instead of multiplying all this into the numeric terms, the constant terms, we multiply it into the x terms. And what do I mean? So this 2 times 2 is a factor of 8, which is 4 is a factor of 8. So we can change this 8 into a 2 in the actual expression. So we just divide 8 by this 4 which we have. 2 times 2 is 4, and we change it into 2. And now we have the 3 also. So we have 4 times 3, right? So this 3 is there, and we can just divide minus 3 by 3. And we have x minus 1. And we divided this one by 3. So now we have to multiply the opposite side x by 3 to equate it out. And this becomes 3x. Same thing over here, we divided this by 4, so we multiply the opposite side x by 4. And this is our factorization. 3x plus 2 times 4x minus 1. It might look a little complex, but once you practice it a bit using this method, it does work out for most quadratic equations as long as it's possible to factorize them. And this is our answer. We have the other two linear factors, which are 3x plus 2 and 4x minus 1. I'll just write out the other linear factors of this expression. And that'll be our answer. Question 4. The 7 digits 1, 2, 3, 4, 5, 7, and 9 are used to make a 4-digit number. In these 4-digit numbers, all the digits are different. A. Find out how many such 4-digit numbers can be made that are even. The first clue, even, and the second thing, less than 4,000. Well, if the number is even, that basically means that the ending digit is even. And what are the even numbers in this list over here? Of course, since the digits are different, there cannot be any duplicates, and the only two ending digits can be 2 or 4. And what about less than 4,000? That basically means the starting digits have to make a number less than 4,000. It doesn't matter what these three are as long as the first digit is less than 4. And therefore, the first digit can only be 1, 2, or 3. And these 2 or 4 is for the last digit. Now, how many such 4-digit numbers can be made? In a number with 4 digits, the order of the digits matters. So we put 1, 2, 3, 4, and we change this to 2, 1, 3, 4. These two numbers are different, right? We change the order. These still have the same 4 terms, but then the order is different and the order changes the number. So we use permutations to solve this. If the order does not matter, then we use combinations, but here it does matter. Changing the order changes the number entirely. So let's make two cases. Because there's an overlap of a number here, we cannot have the ending digit and the starting digit to be 2. So the case number 1 is if the starting digit is 1 or 3. That means for the first digit out of 7 numbers, we can choose 2 digits. So that means out of these 7 numbers, only 2 numbers can be chosen as the first digit. And the first digit is just 1 digit. So out of 2 numbers, 2 digits, we choose 1. So 2p1. And of course, now the last digit. The last digit can be either 2 or 4. And it's only 1 digit. So once again, we choose 1 from 2, 2p1. And now the last one, we have the first digit as either 1 or 3. The last digit as 2 or 4. You have 2 digits in between. So since we chose two numbers, let's just take an example 1 and 2 we chose, we still have these 5 numbers left. And no matter what combination we choose of two numbers, we'll still have 5 numbers left. So out of these 5 numbers, we have to find the 2 middle digits here. And that's 2 digits we have to choose out of 5. And therefore 5p2. And this is for case 1. And what about case 2? It starts with 2. What's the difference for this? The first digit can only have one choice, which is 2, 1p1. What about the last digit? Over here, the ending digit can be even 2 or 4, but then it starts with a 2, so we cannot have another 2. The only digit which is possible is a 4 at the end if it starts with a 2. So once again, we have 1p1. So the digits 2 and 4 are gone, and the rest we have all the odd digits, which are 5 digits. And we have to choose, we have the 2 here, 4 here, 2 more digits we have to choose out of a total of 5. So 5p2. And remember the permutations formula, n_pr is equal to n factorial by n minus r the whole factorial. So in this case, 2p1 is going to be equal to 2 for both of these, and 5p2 is going to be equal to 5 factorial by 3 factorial, which is 20. So we have the total numbers is 2 times 2 times 20, which is the first one here, times plus the second one, which is 1 times 1 times 20. Of course, remember that 1 factorial by 1 minus 1 the whole factorial, that's 1p1, so that's 1 factorial by 0 factorial. But by definition, 0 factorial is 1. And obviously 1 factorial is 1, so these both are 1. And when we add these together, we get 100 4-digit numbers. And that will be our answer. Let's go to part B. Find out how many such 4-digit numbers can be made that are between 2000 and 7000 and have a final digit which is prime. So we have two conditions once again. Between 2000 and 7000. So that means, once again, this is controlled by the starting digits. So it can start with a 2, can start with a 3, can start with a 4, can start with a 5. But it cannot start with a 7, because if you have a 7, the next digit must be at least a 1. And whatever two digits we have here, this is always greater than 7000, so this cannot work. So the only 4 digits are 2, 3, 4, or 5 at the start. And now the first condition is done. The second one is the ending digit. This is very important. The ending digit, the final digit, is prime. And of course, what are the prime numbers inside? We have 1, which is not a prime number. 2 is a prime number. 3 is a prime number. 4 is not. 5 is prime. 7 is prime. And 9 is not prime. So we have 2, 3, 5, or 7. Once again, we have an overlap here. 2, 3, and 5 are present in both lists. So we should separate the 2, 3, and 5 at the start and 4 at the start. So we have two cases once again. 2, 3, or 5 at the start. This is the first case. And the starting digit, the first digit of a 4-digit number, has to be one of these 3 numbers. So we take 3 numbers and choose one, 3p1. And then the second and third digit are not really defined. We'll do that after finding the last digit. So if you have the start as 2, 3, or 5, one of these numbers will be removed from this list. So as an example, let's take 2 as the starting digit. So the number is 2 and 3 more blank space, which we don't know yet. So we cannot have 2 again in the last digit. It has to be 3, 5, or 7 at the last digit. So over here we have 3 choices once again for the last digit, 3p1. And for the remaining 2 digits, because let's just take an example, we selected 3 for the last digit. So 2 dash dash 3. Now we have 5 more numbers left in the list. 1, 4, 5, 7, 9. And out of these 5 numbers, we choose 2 to keep in here. So, similar to last question, 5p2. And this is for case 1. Now what about the second case? We have to start with a 4 as well. That's an option. And this case, we start with only one number possibility. So out of one number, we choose 1. That's 1p1. Times, what about the ending digit? Here, we do not take away any of the ending digit choices. We still have 1, 2, 3, 4 choices for the last digit. And therefore, we choose one number out of 4, 4p1. So now our starting digit is 4, and the ending digit is one of these. Let's just take an example that 7 is the ending digit. We have 2 more. And 4 and 7 are gone, but we still have 1, 2, 3, 4, 5 digits left. And we have to choose 2. So once again, similarly, we have 5p2. Of course, we're using permutations because of the same reason as last time. The digits orders matter because changing the order changes the number. And the total number of 4-digit numbers here, the total number is going to be equal to adding these up. 3p1 is just 3. 5p2, as we found previously, is 20. And then we add this to 1p1 is 1, 4p1 is 4, 5p2 is 20. By the way, just a rule of thumb, if you want to save a bit of time, anything in permutations or combinations, if we take r is equal to 1 and let's say np1, it's always equal to n. Same for nc1 for combinations. It's always equal to n. That's why you can do these very quickly. Even if, let's say, we have 289 or any random number, I guess, this value will be the same number we started with as n. And here we go, let's calculate this value here. 180 for the first one and 80 for a second case, 260, and that'll be our answer. 260 possible 4-digit numbers. Now let's go to question 5. First 4 terms in ascending powers of x in the expansion of this expression can be written as 128 plus bx plus cx squared minus 15120 x cubed. Find the values of a, b, and c. Well, of course, the moment you see the first 4 terms in ascending powers of x of an expansion of some kind of linear factor, or actually any factor to the power of something, this is binomial theorem. So we know that this is where x to the power of 0 is the term. Then this is degree x to the power of 1, the term of degree x squared, degree x cubed, and so on inside a binomial expansion till x to the power of this, which is 7. And we have different coefficients for that. And if you would look at the start of the paper, that formulas page right here, the binomial theorem is literally written right here. And this is the formula for any exponent of a factor with 2 components in it. And this n choose 1, n choose 2, that's how you read it, n choose r. This is basically NCR. That's the formula for a combination. And back to our question. As we saw there, in this case, a plus b to the power of n is that a plus b to the power of n, which is the original form of binomial theorem, is this, where a is equal to 2, b is just ax, and n is 7. And if you remember the formula, we know the value of the x cubed term. And that's basically, we can find the x cubed term and choose r of a to the power of n minus r, b to the power of r. And here, since it's x cubed term, r will be equal to 3 for all of this. We know n, we know a, we know b. So just substitute it. That's going to be equal to 7 choose 3 times 2 to the power of 7 minus 3, which is 4, times ax to the power of 3. And 7 choose 3 is just, if we did it right, 35 times 2 to the power of 4, which is 16, times a cubed x cubed. And that's equal to minus 15120 x cubed. We can cancel the x cubed and therefore we can solve for a. So a cubed is equal to minus 15120 by 35 times 16. And here we get our calculator out. Minus 15120 which is this, and divide by 35, divide by 16 to get minus 27 as a cubed. And a is just the cube root of minus 27. Some of you may remember this, but even if you don't, calculator is always there to help you. We get minus 3. We found our a value by equating the x cubed term, which is given here, with the one we find from binomial theorem. Now we can find the x squared and the x terms using this newfound value of a, and we can equate them to the coefficients, which are b and c. So that's how we find the other two values. So we know a is equal to minus 3. Now let's find the x term in order to find b. So that will be x to the power of 1, and that means r is equal to 1. So 7 choose 1 times 2 to the power of 7 minus 1, which is 6, times ax, which is in this case minus 3x to the power of 1. And I told you a trick already. This 7 choose 1 is 7c1. And I mentioned that 7c1, nc1 is always equal to n for any value of n which is greater than 0. And of course, it is an integer. In other words, n has to be a natural number. And here, n is 7, so we have 7 times 2 to the power of 6, 64, times minus 3 times x. And that's equal to bx. We can cancel the x's, so b is equal to, just do this, negative 3 times 7 times 64 to get negative 1344 as our b value. And the last thing we have to do is finding c. That's the x squared term. Now we just put r is equal to 2 and do this. So cx squared is equal to 7 choose 2, which is 21, times 2 to the power of 5, which is 32, times minus 3x the whole squared, which is 9x squared. We can cancel the x squareds, so c is equal to, we can multiply these out. Once again, calculator is a nice shortcut in this paper to get 6048 as our c value. And that'll be our final answer. Of course, a good practice is to write them all down at the end separately. So a is equal to minus 3, b is equal to negative 1344. You might not see it, but yeah, there we go, negative 1344. And c is equal to 6048. This is our final answer. And with that, I come to the end of part 1 of this paper. Stay tuned for part 2. Thank you very much. This is me, Sanjay Vasu, signing out.